So this is just a hopefully short introduction to integration. So integration is essentially the inverse or the working backwards. Going when you differentiate something, integrating is the opposite. Um, Later on in the chapter, we talk about integration. It turns out to be the area under a curve. Another term used is anti-differentiation. So anyway, just to have maybe some notion what's going on here. So let's do, I have a plot here of lines y equals 2x all the way up to y equals 2x plus 4.5. So you'll see here all these obviously are straight and they all have the same slope. So if you differentiate them, we get dy dx equal to 2, regardless of where I put that y equals 2x plus whatever. I would always get dy dx equal to 2. Now, so the opposite process of differentiation is called anti-differentiation, which is a term that isn't that often used, or more commonly, integration. Now, unless we are given some information about the original function, we cannot say what the integral or antiderivative is going to be. We can't say exactly what it is, but we can work out what's called the indefinite integral. Because if you notice here, the only thing that separates these guys is the constant term here. So we just don't know what that number is, but we can kind of more or less state the rest of it. So for example, here, we know from above that dy dx is equal to 2. Now to integrate, it's written in this format here, which we'll discuss in more detail later. This kind of stretched out type S. I'll kind of try and draw it. Maybe you might draw it in your copy. Just like this kind of shape here, just a stretched out like sort of S, which is meant to signify sort of sum of as a historical thing. And we'll talk about why they use that notation later. Anyway, so we want to integrate 2 with respect to x. So y could be any number of lines of the form 2x plus some number. So we state our answer as an indefinite integral. So y equals 2x plus c. That is the indefinite integral of 2. So further examples here. So if dy dx is equal to x, what would the indefinite integral of that be? Well, what do I differentiate to give me x? If I differentiate x squared over 2, what would I get? If I differentiate x squared, I get 2x over 2. That's equal to 1x. So therefore, going the opposite way, the indefinite integral of x is x squared over 2 plus c. I must stick in that plus c there because I don't know where exactly. The x squared over 2 is on a graph. And then the same with 2x squared, 2x cubed over 3 plus c, and x cubed will be x to the power of 4 over 4 plus c. Now again, that takes a bit of practice, and we'll discuss later the rules. Actually, there's kind of a simpler way of doing that. So taking one above, now this is where the word antiderivative comes in. So write down 3 distinct antiderivatives of x. All that means is you stick in random numbers for your c here. So it could be x squared over 2. We know the integral of x is x squared over 2 plus something. So here they ask for 3 distinct ones. So you just go x squared over 2 plus 5, x squared over 2 plus 12, x squared over 2 plus 2, x squared over 2 plus pi if you want, whatever. So notice here they say, what is an integral in this example of 2x? An example would be x squared. Another example would be x squared plus 3, x squared plus 4, and so on. Now back to the textbook here for 1 second, which I think I've copied here. So we're going to run time here shortly, but let's see. So on this one here, you've got the same function, but it's a vertical translation. It goes up and down in 2s, and you might realize it here, but the slopes are exactly the same every 2 steps up or every 2 steps down here. For example, at the bottom of the slope there is 0. So they will all have the same derivative, 2x plus 4, all of these curves, because they all start with x squared plus 4x. And then in the exercise, they're kind of trying to hit on this, which is probably a good idea. In the first part, they ask you to find out what the derivative is. And then in the second part, you're asked to write down two antiderivatives. So for example, differentiate 4x, you get 4. So that means if I integrate 4, I get 4x plus c. So the answer here would be 4x plus 2 or 4x plus 3 or 4x plus 4 for the first one. And that's that. We'll start that tomorrow.